Our world is mathematics because it is all around us. Everything is mathematics. Mathematics is anything. Everything is made easier because of mathematics. Whether in cooking, singing, painting, citing information, and in technology. We all know that we are the generation of hand technology that provides methods in organizing and structuring knowledge. Within the technology, the number theory evolved. Hi, I'm Capacio discussing about Lesson 3, Number Theory. The title of this video is The Number Theory Towards Technology, since the number theory works more in technology, with the theme identifying the importance of numbers by applying in real-life situations. Number theory, the branch of mathematics which helps to study the set of positive whole numbers. Number theory helps to study the relationships between different sort of numbers. Natural numbers are separated into a variety of times. Even numbers, the numbers that are evenly divided by 2 are called even numbers. Odd numbers, the numbers that are not evenly divided by 2 are called odd numbers. Square numbers, a number multiplied by itself, is called square numbers. Cube numbers, a number multiplied by itself 3 times, is called cube numbers. Prime numbers, if a number has only 2 factors, 1 and the number, is called prime numbers. Coprime numbers, 2 numbers are called coprime numbers if the highest common factor between the 2 is 1. Composite numbers has more than 2 factors. The composite numbers are the prime numbers. The number 1 is neither prime nor composite. Modulo 4, numbers that said to be one number if it leaves a remainder 1 when divided by 4. Similarly, if a number leaves a remainder 3 when divided by 4, it is said to be 3 number. Next is triangular numbers. A number is said to be a triangular number when that number of pebbles that can be arranged in a triangle using 1 pebble at the top, 2 pebbles is next row, 3 pebbles in next row, and so on. Fibonacci numbers are created starting with 1 and 1, then get the next number in the list and adds the previous 2 numbers. Say 1 plus 1 equals 2, and then add 1 plus 2, you get 3, then adds 2 plus 3 gives 5, then 3 plus 5 gives 8, and so on. And now let us proceed in problems and solution. Find the greatest common divisor or GCD of a number 30 and 52. So the divisors of 30 are 1, 2, 3, 5, 6, 10, 15, 20. And the divisors of 52 are 1, 2, 4, 13, 26, and 52. So the common divisors in 30 and 52 is 2. Therefore, the GCD of 30 and 52 is 2. So next is find the common factors of 10 and 16. So the factors of 10 are 2 times 5 equals 10 and 1 times 10 equals 10. Therefore, the factors are 1, 2, 5, and 10. And the factors of 16 are 4 times 4 equals 16, 1 times 16 equals 16, 2 times 8 equals 16. Therefore, the factors of 16 are as follows: 1, 2, 4, 8, 16. Then, the common factors are 1 and 2. Show that the greatest factor of a number is the number itself. Assume that 24, that is not number 21, that is 24. So So the factors of 24 are 1 times 24 equals 24, 12 times 2 equals 24, 8 times 3 equals 24, 6 times 4 equals 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. From this, we can say that 24 is the greatest factor of a number 24. Prime and composite numbers are the two types of numbers that differ based on the number of factors they have. A prime number is the one that has only two factors, and a composite number has more than two factors. A factor is a value that can divide a number or an expression evenly. Prime numbers is the one has exactly two factors, which means it can be divided by only one and itself, but one is not the prime number. Example of prime number: 3 is a prime number because 3 can be divided by only two numbers. For example, 3 divide 1 equals 3. 3 divide 3 equals 1. Composite has more than two factors, which means apart from getting divided with the number 1 and itself, it can also be divided by at least one integer or number. Example of composite number: 12 is a composite number because it can be divided by 1, 2, 3, 4, 6, and 12. For example, 12 divide 1 equals 12, 12 divide 2 equals 6. 12 divide 3 equals 4, 12 divide 4 equals 3, and 12 divide 6 equals 2, and 12 divide 12 equals 1. Types of composite numbers. First is even composite numbers. Even numbers are not prime numbers. That is called even composite numbers. For example, 4, 10, 16, 28, 56, etc. Next is odd composite numbers. The odd positive integers or the odd numbers that are not prime numbers are called odd composite numbers. For example, 9, 21, 33, 45, and etc. Let's proceed to the prime factorization of natural numbers. Prime factorization is a process of finding the prime numbers which are multiplied together to get the original number. It is defined as a way of finding the prime factors of a number such that the original number is evenly divisible by these patterns. These are examples of prime factorization. The prime factorization of 12 is 2 times 2 times 3 equals 2 to the power of 2 times 3, and 18 is 2 times 3 times 3 equals 2 times 3 to the power of 2. And the factorization of 24 is 2 times 2 times 2 times 3 equals 3 to the power of 3 times 3. And the prime factorization of 20 is 2 times 2 times 5 equals 2 to the power of 2 times 5. And the 36 is 2 times 2 times 3 times 3 equals 2 to the power of 2 times 3 to the power of 2. There are methods of prime factorization. First is division method. The steps to calculate the prime factors of a number is similar to the process of finding the factors of a large number. Example of division method for prime factorization. Step 1 is divide 460 by the least prime number. So 460 divided by 2 equals 230. Step 2 is again divide 230 with the least prime number. Now 160 divided by 2 equals 115. Step 3, divide again with the least prime number, which will be 5. So 155 divided by 5 is 23. And step 4, 23 is a prime number. Divide it with itself to get 1. Now, the prime factors of 460 will be 2 to the power of 2 times 5 times 23. Second is the factor 3 method. In factor 3, the factors of a number are found and then those numbers are further factorized until we reach the the closure.
In this figure, we can have number 60 is first factorized into two numbers, 6 and 10. Again, 6 and 10 is factorized to get the prime factors of 6 and 10 such that 6 equals 2 times 3 and 10 is equal to 2 times 5. If we write the prime factors of 60 all together, then prime factorization of 60 equals 6 times 10 equals 2 times 3 times 2 times 5. Same is the case for number 282, such as 282 equals 2 times 141 equals 2 times 3 times 47. So in both cases, a tree structure is formed.
And the fourth topic is the greatest common factor. The greatest common factor is commonly known as GCF. It is also known as highest common factor or HCD, highest common factor or HCF, and greatest common divisor or GCD. The greatest common divisor of two or more numbers is the greatest common factor number that divides them exactly factor that is the highest among the numbers.
For example, 15 divided 5 equals 3 and 10 divided 5 equals 3.
There are several methods to find the greatest common divisor of given two numbers. First is prime factorization method. Each given number is written as the product of the smallest power of each common prime factor. This method is applicable only for positive numbers or the natural numbers.
For example, find the greatest common factor of 24, 30, and 36. The prime factors of 24 is 2 to the power of 2 times 3, and the prime factors of 30 equals 2 times 3 times 5. And the prime factors of 36 is 2 to the power of 2 times 3 to the power of 2. From the factorization, we can see only 2 times 3 are common prime factors. Therefore, GCD is 24, 30, 36 is equal to 2 times 3 equals 6.
Second is long division method. In this method, the largest number among all given set of numbers should be divided by the second largest number, and again, the second largest number should be divided by the remainder of the previous operation. This process will continue until the remainder is 0. The third method is Euclid's division algorithm. This method is stated only for positive integers.
This is the GCD formula. If A and B are any number, then the greatest common divisor of A and B can be given by below.
The last topic is the least common multiple. The least common multiple is a value that is evenly divisible by the two given numbers. LCD is also used to add or subtract any two factors when the denominators of the fractions are different. It is also a method to find the smallest common multiple between any two or more numbers.
This is the LCM formula. Let A and B two given integers. The formula to find the LCM of A and B is given below. Also, the formula for fractions, LCM is equal LCM of numerator divided by HCF or the highest common factor of denominator.
Also, LCM, there is different methods. This is important methods by which we can find the LCM of two or more numbers. First is the listing. The least common multiple of any given numbers is first to list down the multiples of specific numbers and then find the first common multiple between them.
For example, suppose there are two numbers 11 and 33, then by listing the multiples of 11 and 33, we get multiples of 11 is equal 11, 22, 33, 44, 55, and so on. So the multiple of 33 is equal 33, 66, 99, and so on. We can see the first common multiple or the least common multiple of both the numbers is 33. Hence, the LCM is 1133 equals 33. Another method to find the LCM of the given numbers is prime factorization. Example, suppose there are three numbers 12, 16, and 24. Let us write the prime factors of all three numbers individually. The factors of 12 equals 2 times 2 times 3, and 16 equals 2 times 2 times 2 times 2, and the 24 equals 2 times 2 times 2 times 2 times 3. So, writing the prime factors of all three numbers together, we get 12 times 16 times 24 is equal 2 times 2 times 3 times 2 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 times 3. So, now pairing the common prime factors, we get the LCM. There are 4, 2, and 1, 3. So the LCM of 12, 16, and 24 will be LCM 12, 16, 24 equals 2 times 2 times 2 times 2 times 3 is equals 48.
Is division method. Finding LCM of two numbers by division method is an easy method. This is the steps of division method to find the LCM. First is write the numbers separated by the commas. Now divide the numbers by the smallest prime number. If any number is not divisible, then write down the number and proceed. Further, keep on dividing the row of numbers by prime numbers unless we get the results as 1 and a complete row. Now, LCM of the numbers will be equal to the product of all prime numbers we obtained in the division method.
Let us understand with the help of examples. Find the LCM of 10, 18, and 20 by division method. So this is the table to divide the numbers by prime factors. Therefore, LCM 10, 18, 20 equals 2 times 2 times 3 times 3 times 5 equals 180. Now, if we have to find the common multiple of two or more numbers, that we have to write all the multiples for the given numbers.
We constantly use and rely on prime numbers for cyber age security. Prime's odd mathematical property is used in encryption and decryption. They are used in generating error-correcting codes used in telecommunication. Mathematics also applied in cryptography, device authentication, websites for e-commerce, coding, security systems, and many more. Technology provides additional opportunities for learners to see and interact with mathematical concepts.
Good day everyone, I am Mangubat, and today I am assigned to discuss the lesson 4, Fractions. The title of the concept is Portions of Fractions. For my objectives, I will define and give examples of the following being stated using clock fraction.
The conceptual framework.
The theme, Learning Fractions, quarter of an hour.
Good day, class. I want you to get a bond paper, fold it, and divide it into 1/8 piece. A 1/8 piece? How can I cut this if I don't know what is 1/8?
Oh, you don't know? Let me tell you how. I am mathematician Pythagoras from ancient Greece, who is credited with being the first to use the idea of a numerator and denominator to represent a fraction. A fraction is a numerical representation of part of a whole number. The denominator tells how many equal pieces the whole is divided into. The numerator tells how many pieces of the whole the fraction represents. Any fraction with a denominator of 1 is equal to its numerator. As you can see, a bond paper is considered as a 1 whole if you fold it once. You now have a 1/2. It is called 1/2, as what I mentioned earlier. The numerator is the numerator tells how many pieces of the whole the fraction represents. And the denominator tells how many equal pieces the whole is divided into. As the bond paper continuously fold, the last total number of the denominator should be multiplied by 2. Example: first piece is 1 whole, or 1/1. First fold 1/1, the denominator is 1 times 2, equals 2, equivalent to 1/2. Second.
Diba yung ka-fold eh? So this is 1/2. I'm done. So what's the next?
Fold represents 1/2. The denominator is now 2 times 2 equals 4, equivalent to 1/4.
Is it 1/4? Okay.
Third fold represents the 1/4. The denominator is 4 times 2 equals 8, which is equivalent to 1/8.
Now I get it. This piece is a 1/8.
That's how the cycle of fractions works. Well, I hope you learn.
Teacher, I'm done.
Types of fractions. Proper fractions. In a proper fractions, the numerator is smaller than the denominator. 2/3. 2 is smaller than 3. 2 is less than 3. 4/7. 4 is smaller than 7. 4 is less than 7. All proper fractions have a value smaller than 1. Improper fractions. In improper fractions, the numerator is greater than or equal to the denominator. 9/5, 9 is greater than 5. 11/11, 11 is equal to 11. A whole number can be written as an improper fraction using 1 as the denominator. When the numerator and denominator are equal, the value of the fraction is 1. All proper fractions have a value greater than or equal to 1. Mixed numbers. A mixed number has a whole number and a proper fraction. 1 and 3/4. 1 is the whole number and 3/4 is the proper fraction. Let us put this mixed number on a number line. From 0 to 1, as whole number, 1 and 3/4. All in all, 1 and 3/4. A quick way to make the mixed numbers into improper fraction, you have to multiply the whole number by the denominator, add on the numerator, write the improper fraction by using the calculated value as the numerator over the original denominator. A fraction is a numerical representation of part of a whole number. The denominator tells how many equal pieces the whole is divided into. The numerator tells how many pieces of the whole the fraction represents. Any fraction with a denominator of 1 is equal to its numerator. Division by 0 is undefined, so the denominator of a fraction can never be 0. Fundamental property of fractions. Ax over bx equals to a over b. We use this fact when we reduce or simplify fractions to the lowest term. 4 over 10 divided by 2 as a result of 2 over 5. Equality of fractions. A over b equals to c over d. We use this fact when we cross-multiply to solve for an unknown numerator or denominator. X over 10 equals 2 over 5 as we cross-multiply the numerator with the denominator on each side, we get the 5x equals 20. Use again the cross-multiply method to get the x, which is equal to 4. Addition and subtraction of fractions require a common denominator. When the denominators are different, multiply one or both fractions by another fraction that is the equivalent of 1 to create a common denominator, then add or subtract. You may be able to multiply the smaller denominator by something to create the larger one. If not, then multiply the two denominators together. Multiplication and division of fractions do not require a common denominator. It is easier to reduce before. Multiplication and division of fractions do not require a common denominator. It is easier to reduce before actually multiplying. To divide fractions, first invert the divisor, second fraction, to get its reciprocal, then multiply factoring before multiplying can help with reducing. On my schedule to rely on to 4 operations of a fraction. First, on the list, self-preparation. I usually do it between 6:30 a.m. to 7:15 a.m. As I combine them in one clock, it shows a piece of fraction, and it matches on 1/4 piece, so I divided it with 4 1/4 and shaded the 3 1/4. And as I add them together, their sum is 3/4. Also, I included the second activity, which is to get breakfast ready. That consumes 30 minutes from 7:30 a.m. to 8 a.m. To know the fraction, I combined them and figure out the 1/2 piece equivalent to 30 minutes of the time schedule of preparing my breakfast. For For my lunch, I usually eat from around 12:10 p.m. to 12:30 p.m. When merging the two clocks as one, represents a one-third figure of a fraction that consumes 20 minutes in having my lunch. Also, one-third is considered as a proper fraction that the numerator is smaller than the denominator. Next on the list, preparation for the next class from 12:50 p.m. to 1 p.m. Combining the scheduled time with the clock shows a 1/6 piece of a fraction that consumes 10 minutes. I subtracted the fraction of lunch and preparation of the next class. To subtract a fraction, you need to determine the LCM of the denominator values. Convert the denominator to the LCM value by multiplying the numerator and denominator using the same number. Subtract the numerators once the fraction have the same denominator values. Simplify the fraction if required. 1/3 minus 1/6 equals 1 multiplied by 2 over 3 multiplied by 2 subtracted by 1 over 6 equals 2 subtracted by 1 over 6 equals 1 over 6. Daily chores from 2:30 p.m. to 5:45 p.m. 2:30 p.m. to 3:30 p.m. consumes 1 hour. 3:30 p.m. to 4:30 p.m. consumes 1 hour. 4:30 p.m. to 5:30 p.m. consumes 1 hour. 5:30 p.m. to 5:45 p.m. consumes 15 minutes. 1 hour is equal to 60 minutes. Adding 60 minutes plus 60 minutes plus 60 minutes plus 15 minutes equals to 195 minutes, and because I have 5 household chores to do every day, I need exact minutes to finish my pending agendas. The equivalent answer of 195 minutes over 5 household chores is 39 minutes. A while ago, I thought of the hours of my time of doing chores, and this is the result of dividing it as fractions. I got 1/9 into 3 shaded parts. Adding them together, 3/9 is the total piece of the 3 hours spent. And the remaining minutes, I separate them in other clock fractions to differentiate their respective shapes. And the remaining minutes, I separate them in other clock fraction to differentiate their respective shapes. Dividing two fractions is the same as multiplying the first fraction by the reciprocal of the second fraction. The first step to dividing fractions is to find the reciprocal. Reverse the numerator and denominator of the second fraction. Next, multiply the two numerators, then multiply the two denominators. 3/9 divided by 3/12, keep, change, and flip is now 3/9 multiplied by 12/3 equals 3 times 12 over 9 times 3 equals 36 over 27. Divide the numerator and denominator by 9 and a result of 4/3. 4/3 is an example of an improper fraction that the numerator is greater than the denominator. How about converting improper fractions into mixed numbers? To convert an improper fraction to mixed number, we need to divide the numerator by the denominator and then find out the remainder and the quotient. Now, the quotient becomes the whole number of the resultant mixed fraction. The remainder becomes the numerator part of the mixed fraction, and the denominator part remains the same. 4/3 equals 1 1/3. 3 times 1 plus 1 equals 4. Keep the denominator stay as 3. 1 1/3 is an example of a mixed number that has a whole number and a proper fraction. Jose spent 2/5 of his money on new shirts and 1/2 of his money on new shoes. What fraction of his money has been spent and what fraction is still left? 2/5 plus 1/2. When adding unlike fractions, the most important thing is to make the denominators the same before adding the numerators together. Multiply the numerator by the same multiple needed to get the common denominator, and 5/10 to get the 9/10. And the last question asks for the remaining fraction that he has left. 10/10 minus 9/10 equals 1/10. A science teacher had a 2/3 of a liter of salt water. He used 1/5 of the salt for an experiment. How much salt water does the teacher have left? The lowest common denominator in the equation 2/3 subtracted by 1/5 is 15. Multiply both numerator and denominator of 2/3 by 5 to get 10/15. Then, multiply the numerator and denominator of 1/5 by 3 to get 3/15. The lowest common denominator in the equation 2/3 subtracted by 1/5 is 15. Multiply both the numerator and denominator of 2/3 by 5 to get 10/15. Then, multiply the numerator and denominator of 1/5 by 3 to get 3/15. Then, add 10/15 and 3/15 to get the 7/15. A recipe calls for 3/4 cup of sugar. Amari is tripling the recipe. How much sugar will be needed? There are only 3 steps to answer this word problem. First, multiply the numerator, which is 3 times 3 equals 9. Second, multiply the denominator, 4 times 1 equals 4. Lastly, simplify the fraction 9/4 because this is an improper fraction. We need to change this into a mixed number. 4 divided by 9 is 2 1/4. A serving of soup is 1 1/4 cups. A restaurant cook makes 31 1/2 cups of soup. How many people does she expect to serve with that amount? Because the given fractions are mixed numbers, we have to change them into improper fractions to simplify. Write the improper fraction by using the calculated value as the numerator over the original denominator. 31 1/2. 2 times 31 equals 61 plus 1 equals 62 over 2. 1 3/4. 4 times 1 equals 4 plus 3 equals 7 over 4. 62 over 2 divided by 7 over 4. And dividing a fraction, we have to use the keep, stay, flip method. Keep the first fraction, change the operation division to multiplication, and flip or reverse the given numerator to the denominator and the given denominator to the numerator.